Hi, good evening. This is Bala. In today's session, what we are going to discuss is how to generate an RAM signal. So, in our last two tutorials, we have discussed about how we are going to generate an square wave and an triangular wave. A slight modification done on a triangular wave, that signal will become as an RAM wave. So what we have to do is, again we have to go for an tail compiler. You have to create a project. You have to create a file with name ramwave.c or any other name which you like. So type your program, save your program. So now the concept is, first you have to declare on what processor your controller you are working. I am working on LPC2148. I have mentioned here, and I have unassigned my integer, that is nothing but I. That variable I have used in my loop, so I have initialized it here. Again I am going to open my main function of my program. So again what I have does is pin selected. So in our last two tutorials we have discussed how we have to select our pin. So the same concept over here. This is nothing but I have selected my pin as 00008000. That is nothing but, as per my pin select is concerned, it defines two pins. So 19th and 18th pin alone we have to check, or if you are going for here, you have to check only 21, 20, 22, 23. Like this, two pins you have to check as far as my pin select is concerned. So my pins are 9th pin, 19th pin and 18th pin. It is 10. If it is 10 and it is my 19th and 18th pin, my value is nothing but A out, that is analog out I can get. Okay, right. So that I have mentioned like this. So next, when my processor or controller is in true condition, what it does is, first my loop is open, the value is from I is equal to 0, then I less than 1024. That is, you can also mention till 1023, because as you have started from 0, you should mention only 1023. As our recent 20-bit 10-bit ADC, 2 power 10 is nothing but 1024. When starting from 0, it is nothing but 1023 values alone. Okay, so each and every value is forced to the digital to analog control register, and that values are converted into an analog value, and you can set your you can check your output. When comparing to a triangular waveform, I have executed only one loop here. The main difference between your triangular and RAM signal is this. So as far as a triangular signal is concerned, you should go from a low value to an high value, after that from a high value to one low value. But as far as a RAM signal is concerned, it has to go from a low value to a high value. Low is nothing but 0 volt to maximum voltage 3.3 volt, and after 3.3 volt it should suddenly decrease to 0 and it should start from here. So I have eliminated my second loop here, so it will be starting from here to there, and it will be suddenly decrement and going. So the signal will be like an RAM signal, right? So save your program. Then add your program to your existing project, that is nothing but ramwave.c. yeah, add it, close, then run your program. See, you should get 0 errors. So once you got 0 errors, you can go for your debugging mode, setup. So you should remove the all other pins, and you should select only your A out pin, because you have configured A out pin by using your pin select. Okay, so click close, save your program, then run. So I think now you can check your output here, then stop your program. See, it starts from here, it goes on increasing. So once it attains the peak value, that is 3.3 volt, it stops there to it stops and it goes back to 0. So you should select here. See, the value is 0, first value is 0. If it is a peak value, right, so its maximum value is 3.28 to 3.29. that is 3.29 is nothing but 3.3 volt. The maximum voltage is 3.3 volt. You can again you can zoom and also you can take your output, right? See, 3.29678, that is nothing but 3.3 volt. So you have generated a RAM signal successfully. So In our next tutorial we can discuss how we are going to generate a sine wave. Okay, thanks for watching us. Kindly subscribe us and kindly promote our site to your friends also.